Tulanjan?
Okay, I think there must be a problem in the internet issue. Good evening, everyone. Uh, so today, this is a webinar organized by the Institute of Engineers Sri Lanka Water Forum. So first to start the proceedings, I would like to invite Engineer Janaki Migastanna to start the opening with the opening remarks.
Thank you, Dr. Chamal. Can you hear me? Am I audible?
Yes, we can
Okay.
hear you clearly. Yeah.
Okay. Good afternoon to all of you. On behalf of the IESL Water Forum, it is my uh, great pleasure to warmly welcome you to today's webinar on the very important and timely topic of social hydrology. First of all, I extended my heartfelt welcome to Professor Sivapalan. We are truly honored to have you with us today, sir. Thank you, Professor, for giving us this valuable opportunity to learn from one of the pioneers of this field. I also take this moment to acknowledge that several of your batchmates are joining the session coordinated by Dr. Engineer Godaliadda. A warmly welcome to them as well. I would also like to warmly welcome Dr. Engineer Chamal Pereira from University of Moratuwa, who has fully coordinated this webinar. Dr. Chamal is not new to water sector as well as irrigation department, and we deeply appreciate your continued support and collaboration. For the first time, the Institute of Environment Professionals in Sri Lanka, IEPSL, has joined hands with us for a water forum event, and we are delighted to have their participation. A warm welcome to all members from IESL and secretary and others from the Water Forum Committee and the IEPSL. When I brief the introduction to the social hydrology, today's session focuses on social hydrology, an emerging discipline that examines the two-way interaction between water system and human society. It recognizes that water management is no longer only a technical or engineering function. Human behavior, community practices, in institutional decisions, cultural values, and policy responses all shape how our rivers, tanks, reservoirs, groundwater, wetlands, and water bodies and irrigation system evolve. In simple terms, social hydrology helps us to understand how people influence water and how water in turn influence people. This approach is essential for addressing today's challenges, increasing climate variabilities, floods and drought risks, groundwater stresses, land use changes, communities settling in vulnerable areas, complex decision making involving many stakeholders. By integrating engineering with social understanding, social hydrology strengthens our ability to design resilient water systems, engage communities more effectively, and ensure sustainable management of our water resources. With that brief introduction, I once again warmly welcome all participants. We look forward to an insightful and thought provoking session that will deepen our understanding and broaden our approach to water management in Sri Lanka. Once again, I warmly welcome Professor Sivapalan and thank you so much.
Okay, thank you very much, Engineer Janaki, for that introduction. So, warm welcome to all of you. So for Professor Sivapalan, who is joining us all the way from Illinois, it is still early morning. So thank you very much, Professor, for being with us today. And our sincere apologies for asking you to join at such an early hour. Uh, so back in July, when I met Professor Siva during the second International Socio-Hydrology Conference at the University of Tokyo, so I invited him to deliver a talk to the Sri Lankan community on socio-hydrology. So recently I contacted him and with the support of engineer Dulanjan, so we were able to organize this session. So actually, socio-hydrology is still a relatively new field, and although we have many real world examples here in Sri Lanka, only a few people seem to be fully aware of its concepts and the relevance. So that's exactly why today's session is timely and important. So today's session is centered around the theme bridging engineering and society in water management based on the insights from social hydrology. So as engineers, we often focus on efficient technical side of the solutions. So, but when these solutions are implemented without fully understanding the human dimension, so they can unintentionally create new challenges. So those challenges then lead to more interventions, and over time, so we sometimes find ourselves trapped in vicious cycle of problem solution problem. So the purpose of today's discussion is to encourage us to look at these water issues holistically, to recognize not only the physical processes, but also the social, cultural, and the behavioral dynamics that shape these processes. So if we can shift our perspective even slightly, we can design solutions that are not more resilient, more equitable, and more sustainable in the long run. So to help us reflect on this, I think there is truly no one more qualified than our speaker today. It is my absolute pleasure to introduce Professor Murugasu Sivapalan, the Chester and Helen C's endowed Professor of Civil and Environmental Engineering at the University of Illinois at Urban-Champaign. He is a world-renowned hydrologist and one of the co-founder of Socio-Hydrology. Many of you also know him for his pioneering leadership of the IAHS Predictions in Ungauged Basins initiative. So this initiative has had a profound influence on the evolution of modern hydrological science. And Professor Siva is also a proud graduate of University of Ceylon, and his hometown is Jaffna. I believe he needs very little introduction, as most of you already are familiar with his remarkable contributions to our field. For me personally, and for many around the world, Professor Siva has been a true inspiration and a role model. So without taking any more of your time, it is my great honor to invite Professor Murugasu Sivapalan to deliver his presentation to our audience. So if you have any questions, so please post them on the chat box and we will take them up after the presentation. So Professor Siva, over to you.
Thank you very much, Dr. Pereira, and also Dr. Janaki earlier for your remarks. It almost feels like the two of you already have mastered the field of social hydrology to give such a great introduction to my talk. I'm really truly honored to be here this morning on Thanksgiving Day, in the US, talking to the engineering community in Sri Lanka. I have to say that I have never ever entered the Institute of Engineers building, but I've been on the outside on some other trips that I was making in the last few years. But I always wanted to go into the building and find out what's going on there. But today I have a little bit of an opportunity to talk to you, although remotely. I want to say at the beginning that I'm a hydrologist, um, and I'm not a water manager in the traditional sense. If at all I talk about water management today, it'll be mostly from the point of view of an observer. I observe just like I do in hydrology. I look at what water managers do, how do they do it, and what are the outcomes, and I try to draw lessons from it. So I'm still wearing the hat of a scientist. I'm trying to understand the world in all its complexity. And So coming back to my talk, water managers these days have this concept of water security or water insecurity, which has a very broad definition. And I realized that this morning I'm hearing about a major flood that is happening in Sri Lanka. And floods are also part of the concept of water security. And I know Dr. Pereira does a lot of work on on flooding from the social hydrology perspective. My work itself is focused more on the opposite side of floods, which is water scarcity arising from hydrologic variability. So the examples that I will use in my talk today uh, uh, unfortunately will not comment so much on the flooding that you're experiencing in Sri Lanka, but hopefully you will realize that what I say about water scarcity applies equally to the problem of flooding. Um, so yeah, I'm going to show you a few pictures without comment. Water everywhere, not a drop to drink. This is a water crisis in an urban situation. This is an example of a water crisis in a rural situation. I don't think that I have to tell you that there is a water crisis being experienced in different parts of the world in different ways. And I think it's sometimes tempting, especially for somebody like me who's a hydrologist, to think that the water crisis is a supply versus demand crisis, that humans need a certain amount of water, nature is not able to satisfy that demand, and therefore there is a water crisis. And so if that is the case, let's try to understand, at a high level, what is supply and what is demand. So talking about demand, so let's look at the question of how much water do we need. Here are some numbers that are sort of used commonly in high-level circles. That we need 1 cubic meter of water per person for drinking. We need 10 times more for washing and cleaning in the household, 10 times more for industrial water use, 10 times even more for agricultural water withdrawals, like food production. So really, if you think about the water crisis, it's not really a drinking water crisis. If at all there is a crisis, it is a crisis because of the amount of water that is used in agricultural production or food production. Let's look at the supply side of things. Supply comes from nature, of course, and this is a hydrology cycle expressed in numbers. The numbers can be misleading to you. I'm going to make it easier for you. There are three sources of water that we have. Two of them are very familiar to you. One is the water flowing in the rivers, Kelari Ganga, for example. The sum total of all the water flowing in rivers around the world is 45.5. That means something. The 45.5 means 45,500 billion cubic meters of water per year. And there is groundwater. I put it in a box. That is a water that is stored underground. That 20,400 means really 23.4 million billion cubic meters of water. But there's a third source of water, which we don't normally talk about, which we now call green water, which is the water that is used in agriculture, the water that plants use for photosynthesis. And that amount is 65.5 thousand billion cubic meters of water. So we are talking big numbers, billions and trillions. So I'm going to make it a little bit easier for you to visualize. So let's normalize it by the world population. So I looked at the current world population to be about 8 billion, rising to 9 billion by 2050, let's say. So we can now normalize the freshwater flows, the water flowing in rivers, 45,500 billion cubic meters of water per year. If you divide by 8 billion people, that works out to 5,500 cubic meters of water per person per year. I can do the same for groundwater, accounting for the fact that groundwater has to be replenished, and that replenishment rate is once in 234 years, and that works out to 6,000 cubic meters of water per person per year. And then I can also do the same for green water, the water that is used up in evapotranspiration. normalized by population works out to 8,000. So the sum total of this is something like 19,500 cubic meters of water per person per year. Remember, we need 1,000. So if you look at these numbers, you should think that, hey, there should be no water crisis. There's a lot of water that we have, but that is misleading because we cannot take all of that water. Nature needs that water too for many of the functions that nature provides us. And if you want to account for it, how much do you want to allow for nature to have? I take the view, a personal view. Hey, let's take 10% for ourselves, the humans, leave 90% in nature. So when I get 10% of the water that I just worked out for you earlier, I had 550 cubic kilometers of water, sorry, 550 cubic meters of water per person per year. From rivers, 600 cubic meters of water per person per year. From groundwater and 800 from green water. Sum total 1,950 cubic meters of water per person per year. Still something like a double of what humans need. But even that is misleading. If that is the case, which there should not be a water crisis. But this is again misleading because that 1,950 is not equally distributed around the world. So you can see here, this is the distribution of river flows around the world. Some places have a lot less than 1,000. Some places have a lot larger than 1,000, like Canada, for example. Australia is misleading. Australia looks green only because Australian population for the size of the continent is very, very small. And you can see Saudi Arabia, Sahara Desert, and so on. They have a lot less water than 1,000 that they really need for water supply. Okay, so that's one problem. The second problem is that the 1,000 that are assumed that humans need itself may be changing. Here's an example of the amount of water that is used up in food consumption in China. In 1961, the Chinese population were only using something like 250 cubic meters of water per person per year for their food. Now look at 2003, that number skyrocketed to something like 800. Now we are already in 2025. You can imagine where that water is. What's happening here? This is because China became richer. As it became richer, it started eating a lot more meat, and meat consumes a lot more water. So, in other words, what's happening is all around the world, the lifestyles are changing. People are getting richer. When they are getting richer, they are consuming more water for food. Okay, so the 1,000 itself is already no longer accurate. So, in other words, so you can see why we have a water crisis. So you can look at all of it together, and we can paint a picture of what's going on around the world in terms of supply and demand. The world as an average, as a whole, supply is going down because of environmental degradation. We are not protecting the water resources. Demand is going up because of population increase and lifestyle changes. But still, right up to here, up to 2050, demand has not crossed over the demand has not crossed over the supply. We are on average the world over, we are fine, but some countries of the world, some countries, especially in Africa, the water crisis has already hit in terms of demand outstripping supply. But I think the water crisis, unfortunately, is more than a supply and demand issue because even if you are surrounded by water, the water is not going to come to your house by itself. You need some kind of an infrastructure to bring the water to the house, and that infrastructure requires some kind of investment. And the question is that investment is not everywhere available. I'm going to illustrate this by some examples. I did a small project recently with my students in Nigeria and in a small village near the city of Enugu in eastern Australia, in eastern Nigeria. This is the source of water for this river of this village, a small creek that is about 3.5 kilometers away from the town, from the village. This is the kind of path that you take to go from the village to the river. And this is the infrastructure that they use to bring water to the house. Young girls, they go every day, they walk 3.5 kilometers, something like 3-4 times a day to bring water and do the household chores with the water. This is an example of lack of infrastructure in a country like Nigeria, which we normally assume to be a rich country, oil-rich country, which still cannot afford to provide infrastructure for a small village near the city of Enugu. Okay, let's move on from Nigeria to where I live, not far from where I live. This is Chicago, Illinois. And Chicago is one of the richest cities in the US, which prides itself as the richest country of the world. And Chicago is sitting right next to the Great Lakes, which is the largest source of fresh water in the whole world. And yet, there was an article that appeared in the Chicago Tribune about 10 years ago that I use in my classes that says that there are rich neighborhoods and poor neighborhoods in Chicago. My son lives in one of the richest neighborhoods in Chicago. The people living in the richest neighborhoods of Chicago are paying 300% more for the same water that the poorest neighborhoods drink as well. 300%, 3 times more. And because many of them cannot pay for that water, the city council comes and cuts off their water supply. And these people have to go and buy bottled water, which is even more expensive than what the city charges. Here's an example of that. So, rich country, poor country, the water crisis is still there, the infrastructure is still inadequate. Let me take you to another example. This is Cape Town, South Africa. And you know that in 2017-18, Cape Town went through something called the Day Zero water crisis. And the ostensible reason for the water crisis was touted to be that it was going through a drought. Okay, so the drought, and then everybody had to face the drought, and fortunately, the drought broke just in time, but it hid an important factor about Cape Town, that Cape Town had two kinds of people. People who lived in houses with swimming pools on the left, and people living in informal settlement who had to go and buy water using coin-operated machines. These are the poor black people living in ghettos. These are two people that live there, and basically in Cape Town, the rich people used up all the water that there was. They had all the infrastructure, all the water resources, and left nothing to the poor people. So quite a lot of inequity in the way that the water is distributed around the population. And you would think that this is a legacy of apartheid, but my colleagues in Sweden did a study around the world. This problem of what's happening in Cape Town is not unique to Cape Town. It's actually happening all around the world. The urban water crisis that we are driven by elites' unsustainable consumption. Okay, so this is not a local problem. This is a global problem. And coming back to Cape Town, there was a comment made that of course the rich people suffered as a result of Day Zero for a few years, but the poor people, for them, every day seems like Day Zero because they never saw any change because of the Day Zero problem. Okay, so this is another example. So what it says is that the water crisis that we see is not just a problem of supply versus demand. It's also a problem of inability to pay for and maintain infrastructure. But it's even more. It's actually a governance crisis. Okay, the crisis is a governance crisis. We can manage electricity much better. We can put man on the moon. We can do all of those things. We have telephones now available everywhere. But when it comes to water, there is a problem. So the water crisis is a crisis. We say that water crisis is a crisis of governance. Okay, it arises from people. So why is there a crisis? Why is it a governance crisis? Because humans have to make decisions, as we saw in the many examples that I showed you, choices and trade-offs between one and the other, choices between our livelihood and the environment. What kind of, in terms of equity, rich versus poor, upstream people, downstream people, city versus rural, agricultural use versus drinking water use versus industrial use. All of these choices have to be made, and when we don't make the right balance, it creates crisis. There is also an appropriate balance that needs to be made between meeting short-term needs and their long-term consequences. Okay, and all of this has to be done under our cultural norms that we have. Okay, and these cultural norms are not adapted yet to these kinds of problems. This is probably why we are having problem with the water crisis. So in social hydrology and in environmental science, there is a slogan that we always use. It's called the tyranny of small decisions. Some of the engineers in the audience will realize that they are hardworking engineers. They go to work every day. Every day they make decisions that they think are good. But I think that the decisions that they are making are day-to-day, small-scale decisions. Even when they make the right kind of small decisions, they are missing something that may be happening underneath their feet. There are long-term that they miss out, and what they miss out in long term contributes to problems that only show up later. This is what I mean by tyranny of small decisions. I will nowhere is this problem more evident than this place that I'm going to explain. This is, I don't know, some of you may not be able to immediately recognize where this place is. This place is in Jaffna. This is, if you go to Jaffna now, everywhere you see water bottles. People carrying water bottles, people selling water bottles. It's become a way of life in Jaffna. Jaffna that I'm more used to, Jaffna that was famous for reliance, self-reliance. They relied on the wells. Every house has a well like this, and they have lived like this for thousands of years, and now suddenly they are facing a crisis. And to solve the crisis, we have now introduced technology. This is the picture of the $350 million desalination plant that was recently completed. And I'm not going to comment so much on this. It's a highly emotive issue, the crisis in Jaffna. And I don't have enough time to talk about it. But all I can say is what I see in my regular trips to Jaffna is increased commodification of water. That it's now bottled water consumption is everywhere. I'm seeing water service stations selling reverse osmosis water and not addressing the root cause of what caused the crisis, the groundwater contamination as a result of excessive pumping, and going for technological solutions that bring water from external sources. So I am tempted to think, with my experience looking at the problem around the world, that the people of Jaffna are sleepwalking into a water crisis. They don't know what's coming. So, concluding this first part of my talk, water crisis, you will realize by now that it is not just about water. In fact, I see that it is really about us as people. Okay, so that's the first message that I would like you to take from what I've experienced, what I've presented to you. Water crisis is not about water, it's about people. But actually it gets worse. It's worse because we people not only have trouble making decisions, making choices between this and that, but we also change our minds. We change, as the cartoon says, the computer predicted that I would have a sandwich for lunch, therefore I ate cake. So this all comes from what we call human agency, that humans adapt to new information, including predictions about their own behavior. And I'm going to illustrate it through a few examples from social hydrology. So let me start with one example. I was not part of this study, but this is important in the context of what we are seeing in Sri Lanka. That let's say that you take a city like Melbourne, Australia, or Colombo. Let's say that Colombo is going through a water scarcity problem, and somebody in their wisdom decides that to solve that problem, they are going to construct a new reservoir to store water and distribute it. Okay, works well. It has worked well in a lot of different places. Only thing is, after a while, the moment that the new water source is introduced, people think that, oh my God, now we have water, and a lot more, and more people will then move in. That's the psychology. Because water is now available, the place becomes more attractive. People begin to move in, and the demand again goes up. So you solve the problem temporarily for a few years, and the problem comes back because of people behavior, people coming in that you did not anticipate. Let me take you to another example in Western China where I actually did some work, and this is a classic problem in social hydrology. So what happened in Xinjiang province in Western China? This is a very, very, very dry place. Annual rainfall is only 50 millimeters. And yet the Chinese government, with the water coming from the mountains, snowmelt water coming from the mountains, managed to introduce large-scale agriculture to this area, growing cotton and chilies and tomatoes, and very successful, and moving people from mainland China into this area, and as a result, as a result of agriculture in consumption, these rivers started drying, and then it was an embarrassment to the Chinese government, and the Chinese government then imposed some solutions from externally. They gave subsidies to the farmers to basically do what they call plastic mulching. So the farmers were given money to cut down evaporation by covering their farms by plastic mulch, plastic cover, and which they did. I have seen it extending for hundreds of kilometers all over this western province, plastic mulching, basically with holes only for the crops. And as a result, the irrigation efficiency improved, and the hope was that with the increasing efficiency, rivers will start flowing and the environment will return. Only thing is it did not return. Here's an example of what happened. So efficiency went up, as you can see the left figure. Efficiency went up quite a lot as a result of plastic mulching, but consumption also went up at the same rate. Why did that happen? It happened because Chinese government did not foresee the consequences. What happened was that the farmers realized with the money that the government gave, they cut down evaporation, they cut down the losses. Now they have extra water on their hands. What can they do with it? Well, there was no limit to how much land they can irrigate. So what they did, they went out and grabbed more land and irrigated more land and used up all the water that they saved. So the rivers did not get their water back, and the environment continued to degrade. This is an unintended consequence, which we now call irrigation efficiency paradox. Let me go to another example. This is the example that started social hydrology for me. This is in Eastern Australia, in the Murrumbidgee River Basin, which is part of the Murray-Darling River Basin in Eastern Australia, a major river basin in Australia, major source of food production. Let me tell you what happened in this river basin. Now, I have to take you back to the beginning of the 20th century, the end of the First World War. Soldiers returning from the war, they were given land. This area was largely unpopulated except for the Aboriginal people. This area was unpopulated. Soldiers were given land and encouraged to do agriculture. So they went in. There was no infrastructure there. So they started with nothing. They started using the land. They extracted water from the rivers and irrigated. Through the irrigation, they produced a crop, and they generated a profit. With the profit that they had, they invested in infrastructure. They built dams. When they were able to build dams, they were able to irrigate more land. So they irrigated more land, they produced more crop, more profit, and they used the profit to build more dams and more dams and so on. That is what you see in the top left picture. The building of dams systematically over a 50-year period kept on building dams. And the place was become very attractive, and the area under irrigation went up. You can see the orange line here. Population went up because the place was very attractive. A lot of people moved in. Population is going up. Rice production went up. So everything was on the upswing. It was going up and up and up. And the engineers, they managed their water, they managed their agriculture so well. Their productivity was very high, so much so high that after a while, not a drop of water was flowing downstream. The rivers started drying downstream of the area. So almost no water was flowing from the Murray-Darling River Basin to the Southern Ocean. So, and as a result, the environment started to degrade. The billabongs dried up. The migratory birds coming from Siberia stopped coming. all of that happening, and the people began to get upset, especially the Green Movement, and they started putting a lot of pressure on the government to return the environment. And there was a major drought that happened in 2009 period, 1990s, late 2000, and as a result, the government had to act, and did through several actions. They basically forced the farmers, especially the more inefficient farmers, away from farming, and they moved back to the city, moved to the cities, and that's what you see here. Everything was going up until about 2000, and then it was going down. Okay, and we call it a pendulum swing, an unintended consequence that happened over a century period as a result of a competition between farmers, agriculture, and the environment. And eventually the environment won out. And I came into this, and I wanted to understand this phenomenon. And I built a numerical model, simulation model, to understand and explain what happened. And I'm a hydrologist, as you know, and it turned out that hydrology was only one small part of this whole model. It had a component that focused on irrigation, population size, demography, hydrology, ecology, and also sociology. So we had to build a model that has all of these elements built in. And through this model, we were able to replicate what happened over this century period. I'm just presenting to the example to demonstrate this model that we generated was able to explain what happened and why it happened. Okay, and why it happened is explained in this figure. Essentially, it's the cycle. So you can see on the top left, farmers extracting water from the river. That's the first thing you do. Result is reduced stream flow downstream. Reduced stream flow means environmental degradation. That's the part C of this figure. When the environment degrades, that degradation is felt in the community, and the community is not prepared to live with it, and start putting pressure on the government to cut down the water extraction. This cycle continued over a period of 100 years. And we now have a name for this phenomenon, learning from lessons learned in China over 2,000 years. We call it the Taiji Tire model. Really what's happening is a competition going on between the productive force, the force that allows you to go in and extract natural resources to produce something and build up to your livelihood, and a restorative force that forces you to bring the environment back. These two, like the yin and the yang, go against each other. That is basically what happened in Murrumbidgee. It happened in China. It happened in Western Australia, which I'm not going to present today. This is the dynamics. It's a interaction and feedback between people and nature, people and the environment that plays out in the real world. Now, I want to conclude by this work. This is a little bit technical, but I did this model, and I was not 100% able to satisfy my critics who said this is only a model. But to my surprise, there were a group of scientists at University of Melbourne. They, inspired by our work, they went back and analyzed newspaper articles for 110 years. The newspaper they studied was the Sydney Morning Herald. They started analyzing the information in the newspapers from 1890 to 2010, and they asked questions. They looked for information in the newspaper articles about people's ideas about their economic well-being and their environmental awareness. And what they found, confirming what we predicted, that over time, initially, when people were poorer, their focus was more on their economic well-being. When you cannot put food on the table, you don't really care about the environment. But over time, as the economy improved, people had money, then they began to care for the environment. And that's what we are saying here. After about 1960, the economic well-being as a motivation for people's life went down. The environmental awareness went up, and this is basically what was playing out in the community. Okay, people change. So essentially, what that says is that we people, our attitudes change, our values change. It's part of our growth as people. Okay, that norms and values and culture are not forever fixed. They evolve in space and time through people's lived experiences. And therefore, in water management, they should be made internal or endogenous in any projections of the future. Now, this idea of people change has been well known for at least 2,500 years. I go back to this philosopher Heraclitus of Ephesus, who had this quote named after him: "No man ever steps in the same river twice, because it's not the same river and he's not the same man." That is basically what we are saying. And I'm going to now illustrate this through a couple more examples which are hilarious to you, which may be hilarious to you. This is an example from Florida, here in the US. Now, what you see in front of you is a meandering river. If you go to Disney World, you will be, if you stay in a hotel, you will be staying in this river basin, in the Kissimmee River Basin. Okay, this is the meandering river. Well, there's a long history behind this. Right after the Second World War, it was still a meandering river, but the people of Florida were suffering from major floods repeatedly every year. They had tropical cyclones. So, and because they were suffering from floods, they went to the Congress. They managed to convince Congress to spend billions of dollars to straighten the river, which is what they did. And you can see the evidence, the legacy of the straightened river on the site here. Okay, so they straightened it. Well, and then that was 60 years ago. And then over the next subsequent 60 years, Florida changed. The people of Florida changed. They introduced Disney World. They introduced Cape Canaveral Space Center. Air conditioning was introduced, so they don't have to suffer from mosquitoes and the humidity. And a lot of new people moved in, especially from New York, New Jersey, rich people, retirees. They moved in because of the nice living condition there. When they moved in, they saw a straightened river, not very interesting to them. They cannot take their dogs along the river. So, and they had money, and this time they went back to Congress and asked the Congress to re-meander the river. And the Congress agreed, and Congress spent another few $billion to re-meander the river, which is what you see in front of you. Okay, so the upshot of this story is two things. One is people change. We change for various reasons, and we can make silly decisions like what they did in Florida. That's one problem. The other problem is that the flooding in southern Florida, in the southern part of the river basin, still happens. But the rich people who live in the upper part of the river basin, they were more powerful, so they were able to win over. So, in other words, even though you have two kinds of people living in this area, people who suffer from floods, people who wanted the environment, and the people who wanted the environment were more powerful because of the money, they won out. That is the story in Florida. So, the social hydrology as a field came out as a response to these kinds of unintended consequences of people and water interacting, people changing, nature changing, and to address the issue that traditional water management ignored these two-way feedbacks between people and water, the two-way feedback, the kind of feedback that lead to long-term unintended consequences. So the social hydrology came out as a result of this thing and to address this problem. Okay, so I'm coming to the end of my talk. I just want to sort of say a few more words about where social hydrology is going. So the social hydrologic approach, as you already heard from me, it integrates hydrology, social sciences, economics, policy, and so on. It is a science that brings all of these together and looks at the water management situation as a more holistic way, okay? Allowing for accommodating long-term human water system coevolution, addressing both biophysical, engineering, and social dynamics, and preparing for the way, paving the way for more predictive and adaptive management. Okay, so this is what I'm saying. And so far, social hydrology is about 12 years old. So far, I think that we have worked more on the science of social hydrology, trying to understand the world, understand what managers do, understand the reasons for unintended consequences. So I would say what we have done so far is might be called theoretical social hydrology. But I think that with the success of social hydrology, without the lessons that we have learned, we are now transitioning to seeing whether social hydrology can actually provide support to water management. So I think we are moving to the era of applied social hydrology. And even though we have not done a lot of work in applied social hydrology, I want to sort of close my talk with a few examples of what we might be able to do as a new science of coupled human water systems. There are three areas that I will highlight where social hydrology has potential to contribute. Number one, um, generalizing from beyond single cases. As you probably know, many of you involved in water management, you look at water management case by case. Every problem is unique, and you understand the problem and come up with solutions. But I think that one realization that we have made is that many of these many of these unintended consequences happen in different parts of the world. They are not unique to particular places. They are generalizable, and therefore I think that we should put more emphasis in learning from other places. Okay, so that is the first part, what we call comparative analysis and cross case synthesis that might actually help ground policy, water management policy, in more mechanistic understanding rather than just case by case reactive management. So that's the first thing that I want to say. The second thing that we would like to do, we can do in social hydrology, is to use the kind of social hydrological models, the models that for example, that I developed for the Murrumbidgee River Basin in Australia, and there are other models that we have built. These models are much broader. They're not just hydrological models. They bring in economics, they bring in demography, they bring in sociology, and so they are more holistic, much more broad scale models, and so they are more capable of capturing what could happen in the future. If the model that you use for management is purely technical, then you're going to ignore, you're going to miss many of the problems that contribute to the unintended consequences. So these models can be used in social hydrology to create what I call the possibility space of possible outcomes, and then we can take the possibility space to the ordinary people and water managers and politicians, and let them decide which kind of future they want for the particular area that they are in. And the third thing is social hydrological models. Social hydrology itself can be used to facilitate stakeholder participation, because social hydrological models can provide more intuitive visual frameworks for collective learning, to explore cause and effect linkages, and to understand the long-term implications of their decisions. So I'm going to illustrate these to a few examples. The first one, I just want to advertise that there is a book that we have published recently, came out in the last week. This is summarizing all the work that we have done over the last 12 years under social hydrology. This book is amazingly, it's open access, so it's downloadable freely. You can copy the link that I've provided here from Elsevier. So this book is downloadable free, and it provides lots and lots of examples of socio-hydrological systems and unintended consequences that we can learn from. So this is the first thing that I just mentioned to you. It has hundreds of examples of socio-hydrological systems that we have studied, and we can learn the lessons from these examples. The second, and here is another example that we have highlighted in the book. This is something that a problem that I worked on in Brazil, northeastern Brazil, and so it's quite an amazing area here. That this area suffered from water crisis for a century, and they have a record of reservoir building, from 1920s to now. And the reason for building reservoirs, starting from large to medium sized to small and so on, happened in response to various aspects of water security. Initially, the focus was on just water quantity. When they solved that problem, they realized that it's not just the quantity that matters. It, access to the water resources also matters. That sometimes the water is actually, the rich people tend to take over the water supply and prevent poorer people to access the water. So access became an issue. And then third thing was reliability. And the final thing now they're going through is water quality. So in other words, what we look for in water security itself is changing over time in response to the management that we provide. So here's an example of Brazil. And I spoke to you about possibility space. Here's a cartoon picture of what I mean by possibility space. Starting from wherever you are, let's say initial condition, depending on the decision that you make, you can end up in many different places. Okay. And I think in terms of energy, environment, food, and many different things. So I think that these broader social hydrological models can paint a picture of where the kind of decision that you make take you. And on the basis of these big picture views of where you might end up in a century or so, you can make the appropriate decisions now, make the right kind of choices of investment and management and so on. That's what I mean by possibility space. And actually, I have done some work like this in China, in Beijing. One of my students from China came in, and he studied the consequence of the so-called South-North Diversion Project. This is a major project that China introduced to take water from the south to the north, including to Beijing. And you would think that bringing so much water to the capital city will solve the problem once and for all. And the reality is that according to our possibility space model, the reality is that I'm just presenting one example. If you bring so much water into Beijing, then the people suddenly realize, oh, now that we have a lot of water, we don't have to do anything. We can continue, go back to our wild consumption patterns, go back to the old consumption pattern, which deplete the reservoir resources and so on. This is what we actually forecast. So in other words, it's not enough to bring water to a city. You have to also have good plans for the long term in terms of how to manage the people. If you don't have that, then you might solve the problem temporarily, but in the long term, the problem will come back. And that was the story from our possibility space study in Beijing. And the final thing, I want to come back to Jaffna, and I'm working with a team of scientists centered at the University of Jaffna, and in an area of research called participatory action research, which involves dealing with people, ordinary people. I'm not going to go into the details of this, but we are doing this systematically by talking to people, getting their ideas about what they are facing, what kind of, we call engaging. We learn from them about the problem that they face and bringing them together and preparing for the future, envisioning, and then on the basis of that, synthesizing in terms of where we should be going and what kind of actions we should be taking. And we are doing this not only with the ordinary people, farmers, and other stakeholders, but also the engineers that are in the area. So this is the third level of research that we are doing through the socio-hydrologic lens. Okay, I come to my final take-home messages. When I give these messages, I'm not only using the examples that I presented from around the world, also my experience from working in Jaffna in recent times. This is what I can tell you. What I've come to realize is that when it comes to the water crisis, there is no silver bullet. Number one, whatever we're going to do is going to be a protracted, complex mix of solution that we need. This water problem is too serious a problem to be left to the experts. Everybody should be involved at all levels. This is a work in progress. It will never ever be a finished product. Water crisis is such a crisis. So I think it's better to focus on the process, not the product. And I think the final comment is that we need to broaden the focus of water management, and we need to prepare always for unintended consequences. We can never assume that our 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 approach is completely holistic. We are always going to miss out. So I think it's perfectly logical to prepare ourselves for unintended consequences. Let me finish my talk with these slogans, these titles of newspaper articles that appeared in Sri Lankan newspapers during a trip that I made in 2018, which encapsulates what I have just been telling you. Broaden the conversation, Imagineering. And that's all I want to say. Thank you very much. I'll be happy to answer any questions.
Thank you very much, Professor Siva, for that truly enlightening and thought-provoking presentation. I think there are so many valuable takeaways for all of us, especially in understanding how knowledge of these human water interactions and the feedback mechanisms can be used to design better solutions for the society. I can already see we have several questions coming in through the chat box. So to get the discussion started, so let me begin by asking some questions from my side. So then we can move to the audience questions. So I think now based on your presentation, I think one major challenge seems to be this balancing short-term water needs with the long-term societal and ecological consequences. So most of the times we see the governments act to meet the immediate demands, but future generations then they have to bear the long-term cost. So in your view, how can we use the socio-hydrological perspective to ensure that these short-term solutions do not compromise the long-term sustainability?
Good question. I don't know that there's a good immediate answer I can provide, but I think that um, uh, this is where engineers and hydrologists like me and environmental scientists can come in, because you cannot, it's our job to educate based on the knowledge that we have, because that's what we do research for, that trying to look at the environment, look at hydrology, everything in the long term, and look at what kind of things are possible, and bring that knowledge, bring that understanding to politicians and water managers. So I think the main role here that I see is education. That education in the sense of what is possible, what could happen, and to uh, presenting a picture to managers and politicians who make the final decision about the consequences of their decisions. I think those are the two areas that we can spend our time on. In other words, trying to understand the world better, to communicate that to the managers, to the politicians. So two roles that we have to play: do the science, and then communicate the science to the people that are important.
Okay. Okay, and also, Professor Siva, so you mentioned that water crisis is a crisis of governance, right? So
Governance.
you mentioned
Yeah.
we recognize the trade-off among the different interests like the upstream, downstream, and then
Yeah.
urban, rural,
Yeah.
rich, poor. So likewise, given these conflict in demand, so I
Yes.
think it's very important to identify the pathways that achieve a balance and sustainable water allocation, right?
Yes.
So in that sense, I think in a diagram you showed the possibility spaces, right?
Hmm.
So if
Yes.
we can identify these different possibilities, so that can guide us in identifying the best decisions, I suppose.
Yes, I think that's what I meant. I think that I mean I mean, by the way, those trade-offs that I was telling you about, those are things that I have identified on the basis of what I have learned over the last 10 years. But that doesn't mean that we fully understand them. We still are in the process of understanding them. So there's a lot to learn in these areas, and using the understanding that we gain through studying different places, bring them into our models, bring them into the tools that we use for projection, predictions, and then paint the picture of where the system might evolve to. So when people invest in these kinds of projects, they know where the system might end up in. So they make their appropriate decisions. So and the models must incorporate these kinds of trade-offs that eventually that we have to make. That doesn't mean that we will know all of them at the beginning, but but we will eventually understand them if we systematically analyze them over time. It's not going to be a immediate solution that we know everything now, but I think in the long term we'll find a way. The important thing is awareness right now.
Okay, great. So I think we have several questions in the chat box as well. So I will just pick one question first. So there's a question from Engineer Edirisinghe. What is the philosophical foundation of socio-hydrology as an emerging discipline?
It's a very deep question. I think if you I think it's philosophical foundation. I don't even know how to answer that question. I think the best I can say, I hope Dr. Edirisinghe is aware of the research we have done on complex systems. So I mean, if you want to ask me, I mean, I'll take it back to these couple human water systems that I study are essentially complex systems. Complex systems mean that the sum of the whole is more than the sum of the parts. That is why we have emergent dynamics, emergent patterns, because 2 plus 2 becomes 5. So I think if you ask me scientifically, mathematically, I think the best answer I can give you that is a complex system that ends up with emergent dynamics, emergent patterns. So they're not easy to predict in more traditional ways. So they pose major challenges to projections because we cannot know a priori where they will end up. I think that's the best way I can answer. Complex systems.
Okay, great. And also there's another question from Engineer Vajira Lasantha. Do you mind unmuting yourself and directing the question to Professor Siva?
Yeah.
Yes, thank you so much. Fantastic talk, Professor. And what I want to ask is that, so as you said, the water crisis are governance crisis, but unlike blue water and groundwater, the whole of green water seems to be left completely ungoverned at present. But do you think there is a need for governing green water as well? And if there is, like, what can we do today as scientists and water managers to make that happen?
I think that's an excellent question. Thank you very much for asking that question because I think most of the people in the audience would not have heard about green water. I myself did not hear about it until about 10 years ago. Green water is a concept that was introduced by Professor Malin Folkermark in Sweden. And essentially, it's the water that it's an important source of water. This is the water that is used in agriculture, food production. And unfortunately, engineers like me, civil engineers, never ever cared about that water as a separate source of water. It's only now in recent times that we started making it part of our analysis. But as you said, I think our governance of water must more and more take that into consideration because, as I told you at the beginning of my talk, almost all of the water that we use for human consumption goes into food production. So, and food production is nothing but green water. So therefore, I think that we need to pay a lot more attention to that source of water and give it special treatment. And the green water is actually even more complex because while water cannot be transported easily over long distances, You cannot take water from the US and send it to Sri Lanka, for example. Water cannot be transported. We call it, bulk water. But the products of water, products that are produced using water can be transported. So agricultural products can be transported from the US to China, from the US to Japan, and so on. So, when you are managing green water, you're also involving trade. I think there's a huge area of research called virtual water trade, and because of that thing. So when farmers make decisions in California, that has implications in other parts of the world. Or, for example, I tell you an example. The price of almonds one time shot through the roof, and so when the almond price went up, farmers in California started planting almond crops to use their, and then California went through a drought, and because they are already invested in the almonds, in spite of the drought, they started pumping groundwater, which is a precious resource, because they had to take care of the investment they made in almond production. So it has a lot of weird consequences. So that's why I think green water is a special case that we need to pay a lot more attention to. Thank you for that question. It's very, very, very important.
Thank you so much, Engineer Vajira. And we have another question from Engineer Manix. Could you please enlighten some thoughts on trans-basin diversion from mainland water resources to Jaffna Peninsula?
Now you're talking about a emotive issue. Now, anytime you take from, I've actually done a lot of work on transboundary river management and conflict and cooperation and so on. So I know a little bit about this. And so what's happening in Northern Province, we have a water crisis in Jaffna Peninsula. And one proposal was to take water from what we call mainland, which is the Vanni area, that is already used in agriculture there, take that water to Jaffna to meet people's mostly drinking water demand. And the farmers of Vanni apparently went up in arms against that proposal. So I think the answer to that question is very complicated, very political, and I only want to express my opinions, and it may not be acceptable to everyone. My attitude to this is that the crisis in Jaffna is a consequence of local decisions, especially overconsumption of water, groundwater, application of fertilizer, and so on. So I think that the first order business that we need to do is to take care of our own problem. In other words, address the root cause of that problem, which is excessive consumption of water, before going to somebody else's water and bringing the water over here. Okay, I think that would be my immediate answer. I think that we need to address the immediate causes of that water crisis in Jaffna, instead of continuing the same style of consumption and going to somebody else and bringing their own water. So this may be controversial, but that's the way I see it. Thank you.
Yeah, and also we have a question from a gentleman from India, Mr. Nitila. Can you please go ahead and ask the question by yourself? You can unmute and direct the question to Professor Siva. Okay, I think what he's asking is, in India, we also have water bodies similar to the Kulams of Jaffna. Have you come across any case study that looks at managing both floods and droughts, as it floods during the monsoon and drought occur during the summer months?
Okay. I have been involved in that kind of study myself. There was, I think we recently published a paper in Water Resources Research on that very problem, and there was also a previous paper in the journal Water Security. Now, let me just explain to you. I have actually had a slide on that problem, but in the interest of time, I will not present it today. But there was, some of you may recall that there was a major flood in Brisbane, Australia in 2011. People, my classmates who live in Brisbane will know that this was the 2011 flood that the city of Brisbane, something like 1 million of the 1.5 million people had to be evacuated. Now, that happened because in Brisbane city is frequently flooded in the past, and they built a reservoir upstream of the city, not only to control the floods, but also to provide water to farmers living upstream. And in 2011, just before 2011, that area went through a major drought, something like a 5-year drought. And the operators of the dam uh, were thinking about the drought more than the flood, because they had already gone through 5 years. So they wanted to keep enough water in the dam to cater to the demand for the next year. That was the mentality. They were thinking more about droughts rather than flood because of memory. Because of memory, they were going through droughts. To their bad luck, they had a huge tropical cyclone that hit the area, poured a lot of rainfall into the catchment area, and the water level in the dam went up dramatically, very fast, and the operators had to make a decision. They allow the water to rise or release the water. And in desperation, they released the water quickly. And it's because of that the city of Brisbane was flooded. So, in other words, it was a trade-off that they were going through, the operators, trade-off between managing flood risk and managing drought risk. And they made the mistake of focusing more on the drought risk at that time than the flood risk, and that caused the flood. To make it worse, this is another socio-ecological problem. To make the problem worse, because the city of Brisbane, the people in the city of Brisbane felt that they were protected from floods anymore because of the dam, they went and built their houses next to the river. Over the subsequent years, they built their houses next to the river, not anticipating that there could be a flood, a major flood in the future. So it happened both ways. So unintended consequence happened, and the city had to be flooded. So that's one example I can tell you. There's a similar example in California. I believe in a similar thing happened in Kerala. There was a flood happened in Kerala, and I believe for the same reasons, through the operation, the actions of the operators. But there was a lot of controversy in the newspapers. The politicians were blaming climate change, but actually, in my opinion, it happened because of this trade-off between flood risk and drought risk. I hope that answers that question. Thank you.
Okay, and we have actually so many questions coming up through our chat box. And here we have another question from Engineer Badra Kamaladasa. Madam, can you please unmute and direct the question to Professor Siva? Engineer Badra Kamaladasa, can you hear me?
She cannot talk. Yeah.
Yeah, I think what she's asking is the concept and model of water stewardship work well in many countries, as it will fix the responsibility of water users in quantity of extraction and quality of discharge. What is your view on this concept?
I didn't fully understand the question. Can you repeat that question?
Yeah, she's asking about the concept and the model of water stewardship.
Water what? Sorry, I didn't get that word.
Water stewardship.
Sorry, can you reply? I don't, that
Yeah,
word.
the concept and the model of water stewardship works well in many countries.
Stewardship.
Stewardship, yeah.
Is it?
Stewardship, yeah.
Stewardship. Okay.
As it will fix the responsibility of water users, the quantity and quality of extraction. So she's asking your view on this concept.
I have actually heard about this concept and seen in the literature. that I mean, again, this is an opinion. When it comes to water, I mean, the dominant concept is that, like I said in my conclusion, don't leave it to the experts. When it comes to water, we say it's the engineer's job. Engineers are responsible for everything, and ordinary people, they're not involved. They're not asked for opinions and so on. So I think that, in my opinion, I think this is consistent with what I said. I think that when it comes to water, we need all players to be involved. So this is a common responsibility, not just the engineer, but the farmers, the manager, the mayor, the governor, all of these people have to come together. It's it's a responsibility of every one of us. That's what I understand about stewardship. That as a community, I think we should take ownership of this together, work together, and solve the problem. Because I think a lot of the places, where there's a water crisis, this stewardship is not happening. I think the solution of the problem is left in the hand of a few experts, and I don't think that, at least in the case of water, I don't think it's appropriate anymore.
Okay, and I think I have another question. I think I'm asking this because this may be relevant to most of our engineers in this session. So I think now some people I have seen, they argue that this social hydrology is the scientific foundation underpinning the integrated water resource management.
Mhm.
So given that many of our engineers here are trained in IWRM tradition, how would you recommend them to shift their mindset or expand their perspective, like to think like a social hydrologist instead of a traditional IWRM practitioner?
I think that's
So
a very, very good question. I think all of us, including myself, are trained in the IWRM concept, and um, the 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 most important thing. I mean, of course, this takes time. Number one, but the most important thing for us to appreciate is the now overwhelming evidence of unintended consequences coming out as a result of two-way feedbacks. Okay, this is something that is not fully appreciated. So if we want to move forward and broaden IWRM, I think the first thing that we need to do is to accommodate the possibility, the fact that um, coupled human water systems co-evolve over time, and so we need to accommodate that. Number one. Two, I think we need to look at much more long term that we have done in the past. And finally, I think IWRM already does, but I think that we need to bring in the social, the economic perspectives into our model, and bring them, social scientists and economists, into our analysis of systems in a more equal way, and so that we can learn from each other. So those are the three things that we need to do. So coming back to the engineers, I think that what they need to go through is it's a whole process of re-educating themselves, like I said earlier, through looking at case studies around the world where these coupled human systems are co-evolving, resulting in unintended consequences. So I think we need a process of re-evaluating and re-educating in the context of the history of coupled human water system studies that have been done around the world. I think that's the way I would go. I think at the moment, my understanding is that we are in a mindset where the experts decide what needs to be done. I think we need to broaden it. So broaden the conversation is my slogan. as I said earlier. It's a very good
Okay.
question. I think this has to be done not by individuals, but by the engineering community, the water system community. That you, for example, you have a water forum in Sri Lanka and under the Institution of Engineers Sri Lanka. So I think that you can do many things under under the forum to bring about more awareness of these kinds of problems and the possible re-evaluation of the approaches that you typically adopt in solving water management problems.
Okay, excellent. I think we can take few more questions. So there's another question from Engineer Nihal Fernando. Engineer Nihal, could you please unmute and direct the question to Professor Siva?
Okay, thank you very much. Do you hear me?
Yes, we can hear you clearly.
Okay. Thank you very much, Siva, my friend, for your excellent and thought-provoking presentation. I have a question, but let me make a very quick comment on my view on the socio-hydrology as applied to Sri Lanka. I think the best example of socio-hydrological applications come from Sri Lanka, as evident from the ancient hydraulic civilization pioneered by ancient kings that led to the creation of very impressive hydraulic infrastructure to sort of address supply and demand more than 1,000 years ago, and also which really created which I would consider as a hydrological wonder. Those days, the tank cascade systems which tamed the rivers and to meet the supply and demand, and all for the benefit of the humans as well as the animals as well as for the environment. So that's a comment. But my question is, Siva, I agree with your statement that water crisis is a governance and also a human issue. But I would rather argue that it's not only a governance and a human issue, it's also a political issue. And you may agree with me that in the recent times, river basin management has emerged as a solution to address governance, technical and human issues in addressing water crisis at present and also in the future. So several countries, several parts of the world, like in Mekong River Basin, and Nile River Basin, and also Murray-Darling Basin, there are efforts to sort of, broaden and strengthen the governance to manage international waters, particularly for the rivers that run across several countries like Nile River, and also like in India, where there are several interstate rivers where the water crisis is very acute. So how do you see the relevance of the application of the socio-hydrology to address river basin management and also addressing water crisis in international and interstate rivers?
Thank you. This is Nihal Fernando, right?
Yeah, I'm Nihal, your batchmate.
Nihal is my batchmate. So, yeah, thank you, Nihal, for this wonderful these two questions, actually, comment and question. Really wonderful questions. Let me answer them. I want to take a few minutes on that. First of all,
Yes.
The first comment you made about lessons we can learn from Sri Lanka.
Yes.
I tell you, I am 100% in agreement with you. In fact,
Yes.
I want to give a shout out. There's Chamal Pereira who is here, but there's
Yeah.
also a Sri Lankan student who is doing a PhD in Japan.
Yeah.
I think his first name is Rohita Vikramanayaka. Vikramasinghe, I can't
Ro-
remember his last name.
Romita.
He's in the audience, I think.
Yeah, I
And
think he's in the audience. Yeah.
I tell you, Nihal, these guys, both Shamal and Rohita, but also their advisor, Shinichiro Nakamura, in fact, he's also in the audience, I see. See, these
Yeah.
guys are doing wonderful work in Sri Lanka.
Yeah.
And in fact, they are actually studying. Rohita did his PhD on comparing the resilience of water management using the old network of reservoirs that we had 2,000 years ago with the new, the Mahavali thing. And they
Yeah.
found, this is the paper published just recently, they found the old system is much more resilient.
Mm.
So,
Yeah.
so I think that, I mean, by the way, I mentioned about Jaffna. Jaffna too, not as famous as what you have in Bani area. We too, in around my village, we have small ponds, small reservoirs built by the kings. I don't remember when they did it. They served a beautiful function, solving the problem of flooding as well as scarcity. And one wonders how they managed to come up with this kind of wisdom 1,000 years ago or 2,000 years ago.
Yeah.
They did. And in fact, and now social hydrology through the work of Romita is actually demonstrating that it made a lot of sense.
Yeah.
So number one, I completely agree with you that we can learn lessons. In fact, I believe that this is not only true of Sri Lanka but also of India. I know about also in Japan. So in other words, many Asian countries have a lot of wisdom to contribute to. And I think that this was one of the conclusions of the Japan conference in sociohydrology earlier in July, that I think we need to put a lot more emphasis on learning
Yeah.
about sociohydrology and water management from Asian countries historically, so through historical
Yeah.
studies. So this is the answer to your first comment, that
Yeah.
we can learn a lot if only we paid attention to these things. Instead of, my favorite language, instead of going and aping the West, okay,
Yeah.
learning from the West and coming back and solving our problem, we can learn from our own history. Okay, I
Yes.
think that's number one comment, answer to your first comment.
Yeah.
We don't do enough of it, and I think that social hydrology now offers an opportunity to go back and study our own system in a systematic way, and present some lessons for the rest of the world.
Yes.
Second thing about the political aspects, and I 100% agree with you. And I've actually done some work on that, the transboundary conflict and cooperation work.
Yeah.
In 2019, just before COVID, I brought in something like 12 students from around the world with their professors to Kunming in China, and we worked for 6 weeks studying
Yeah.
comparatively three transboundary river basins: the Nile, the Mekong, and the Columbia River Basin in the US, between US and Canada.
Yeah.
And everything that you mentioned was studied, especially the um, the more political, more geopolitical issue, how that plays out. Effectively, for example, in the Mekong River, that where China is building a lot of dams upstream, and the effect of the dams being felt in Thailand and Vietnam and so on. How do you study that problem? How do you manage it? How do you do geopolitics with water management? What can China do? For example, they generate a lot of electricity, and the country downstream are affected. How can they trade off? So we give you something and you give us something. I mean, this kind of thing has to be incorporated in the thinking. And actually, Nihal, if you want, I mean, the others may be interested. We actually published a paper on how to approach this more philosophically. Learning from the three different case studies. So
Yeah.
there's a lot more we can learn. I mean, I think this, as you said rightly, that it not only applies to between countries, but between different states in the same country. For example, between Tamil Nadu and Karnataka, India, they are fighting over the Kaveri River sharing of waters.
Yeah. Yes.
And now some an audience member this afternoon, this evening, asked a question about the conflict between the the Jaffna Peninsula and the mainland, which is the Vani area. That is a
Yeah.
transboundary conflict, and
Yeah.
there are ways that we can manage it using social hydrology concepts. But it is not fully worked out. But I think there is a lot of opportunities to do that. So
Yes.
I'm glad that you asked that question. Is very much in our minds, and I think that we'll be doing a lot more work in that area in the future.
Okay. Thank you very much, Siva.
Thank you.
Professor, we have so many questions in the chat box, but unfortunately, we don't have time to go through all those questions. But let me pick some questions. So we have a little bit long question from engineer Umapati Gujaruban. could you please unmute and direct the question to Professor Siva?
Can you hear me?
Yes.
Yeah, we can hear you.
Okay. Actually, my question I don't think is directly related with today's topic, but there's the one slide Professor Siva mentioned about that plastic cover in China. And my concern in Sri Lanka also now, I noticed that nowadays the plastic usage in agriculture base system is keep increasing, and the companies started to promote, and they are bringing a lot of product from other countries, and they are encouraging farmers to use that. But my concern is if they use some plastic product with agriculture, they have to abandon, they have to throw it out on timely manner. Otherwise, it will deteriorate it, and it will become microplastic or nanoplastic, and it will pollute the agriculture product as well as all water bodies and groundwater. In this case, in your perspective, how can we deal this situation in Sri Lanka? Thank you.
Okay. Thank you very much for asking that question. I don't think I can answer that question because it's not really related to what I talked about. All I can say is plastic pollution is a serious problem. The whole world is now looking at it. Even hydrologists, there's a separate field of study dealing with plastic, microplastic, and so on. So I think all I can say is that I think we need to take it more seriously. And I mean, first order business, I think we should cut back on the use of plastic. The plastic that was used in China is really only as a mulch. So it's not the same problem that you are describing. What you are describing is a much more serious problem. And I think that we need to address it in a different context, not in the context of my talk. But thank you for asking that question anyway.
Okay, thank you. So we have a question from Dr. Godaliadda. Can you please unmute and direct the question?
Hello.
Can you hear me?
Yeah.
Yeah. Hi, Siva.
Hi.
I'm Godla. Yeah, I have a very basic question. When we were in the campus, in the geography department, they study hydrology. But their hydrology is quite different. It's not descriptive hydrology, but I have come across, they look at in a different angle. It has some connection to this social hydrology that we are speaking, because they don't have any maths or anything, but they talk about geological patterns and various things, and human interventions and various things. So are we going on something related to this? But I know it's a different thing, but what is your opinion?
That's a very good question, Goda. But by the way, for the audience here, Godaliadda is another batchmate of mine. He used to be the now retired director of irrigation here, so he's an important person, and I'm a great friend of mine. But thank you for asking that question, Goda. Many of the people in the audience don't realize I hold a joint appointment in 50% in civil and environmental engineering. I'm an engineer, trained engineer, also 50% in the geography department. And so I have a perspective to communicate. Now, for sure, I think that there is a different perspective. Geographers have a different perspective. Especially they're very proud of looking at things in space, how things vary across places, across scales, and how things are connected between places and between scales, people, landscapes, how they are connected. I think that the geography perspective is especially important to hydrology and social hydrology. The other thing that geographers offer, which we don't realize, in my department in Illinois, the geography department is divided into physical geography. I'm in the physical geography part, and human geography. So you have a bunch of people in the same department who come in, look at problems that have a social dimension, human dimension, and a natural dimension. I think that when it comes to social hydrology, when it comes to water in general, as you heard from me, we need to look at it from both angles: the natural engineering, natural science and engineering angle, and the social science human angle. We need both of them, and the geography discipline offers both of them in the same department. So I think we can learn a lot from that geography perspective. Of course, as Dr. Gordillier just said, yeah, they are less mathematical than we engineers. But again, I think even that we have to take a closer look at this. This so-called dominance or advantage that we engineers have, that we are mathematical, we are quantitative. The social scientists are not quantitative, and many social scientists resent that. It prevents us from working easily with social scientists. But as you heard from me, in order to solve the water crisis, we need to work with social scientists. We need to work with economists. So we need to begin to respect them, regardless of whether they are mathematical or not. With regard, respecting the perspectives that they bring, that we need to respect. So I think that the geography department offers an excellent vantage point, to excellent place to bringing these different perspectives together. So in answer to Dr. Shamal Pereira's answer earlier, how can IWRM advance benefiting from social hydrology? I think that we need to prepare the ground for more social scientists and geographers to come in and participate in the work that we do if we are serious about solving these problems. So I think it comes from both directions. I hope that answers
Thank
the
you.
question.
Thank you, Siva. I think it's correct. Yes, that's what I was expecting. But one more thing I want to add. This social dimension.
Yeah.
We worked in irrigation department. We came out with a lot of engineering principles. When we went to irrigation systems, there we have to work with many disciplines: agriculture, farmers, social
Exactly.
scientists, administrators, and all sort of people. So it's a sort of a exercise we are doing, not on a arranged basis, but throughout our life, it was the case. So that's I want to add.
Yeah, I think we can learn a lot from that experience, Goda. And I think that, we in social hydrology want to benefit from that experience because
Thank you.
we can enrich our understanding of how systems work.
Thank you.
Thank you.
Okay, thank you. I think we can take another one or two questions maybe. There's one question I'd like to direct to Professor Siva. Engineer Sudarshan, he's asking about the unintended consequences, water transfers. Engineer Sudarshan, can you please unmute and direct the question? Okay, let me read out his question. He's asking, given the need to prepare for unintended consequences, what safeguards should Sri Lanka incorporate when implementing large-scale water transfers, multi-purpose reservoirs, and groundwater extraction schemes?
Yeah, I think that's a very good question. Thank you for asking that. I have been thinking about that. I have not done much work in the rest of Sri Lanka. So my focus in recent times has been in the problem of in Jaffna. And I have been advocating that the solutions that have been bandied about in Jaffna tend to be very narrow. And I think that we need to broaden the conversation there and look at many things. For example, when it comes to unintended consequences. For example, let's say that we bring an external source of water to Jaffna and start distributing it. What happens to the water after you flush the toilet? Where does it go? So most people talk about water coming in, but nobody I have he talks about where the water has to go afterwards. Um, uh, when more water is introduced into Jaffna city, for example, with the availability of water, I bet you in 10 years there'll be a lot more hotels being built. Where is the wastewater? When the hotel guests flush their toilet, where does the water go? Um, when I mean, there are so many things that can happen, and I think I mean, what happened to the? I mean, another question in the context of Jaffna, what is the long-term future for Jaffna's economy? Right now, Jaffna's economy is built on agriculture. Agriculture is the very activity that contributes to the degradation of groundwater quality. So, what's the future of agriculture in Jaffna? These are the kind of questions that, I mean, if agriculture collapses, agriculture is no longer sustainable, what will be the future of Jaffna's economy? These are the kind of questions that we should be asking in the long term. We cannot just talk about water, 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 and ignore all these other questions. And I think that is why what I mean when I say we need to broaden the conversation, that we need to think ahead what the economy will look like in 2100. We are very good at predicting climate. Everybody I talk to in Jaffna talks about climate into 2100, which was really silly to me, but that's what they are doing. But they're not thinking about what the economy of Jaffna would be like in 2100. So I think that broadening the conversation, possibility space, all of that means that we need to think like that if we really are serious about addressing the water crisis. I hope that answers that question, Sudarshan.
Yeah, I think Professor Siva, in connection to that, so I think in many water resource challenges, we see a tension between these fast moving variables and slow moving variables, right?
Yeah,
So for
that's right.
example, the over extraction of groundwater, it may supply water immediately, but in the long term, it may impact the aquifer, and it will cause issues for the water security. So given this,
Also economic security, not just water security. That's the
yes,
problem, because
exactly.
it has
Yeah,
got follow-on consequences for so many other things that we don't think about.
exactly. So given this, how can socio-hydrological analysis can help the water managers to better recognize this and give due weight to these slow-moving variables?
Well, first of all, start considering them in the first place. I mean, so start bringing them in little by little, educating, getting. I mean, one thing that I would do if I'm a water manager, go and talk to the people. Go and talk to have a culture of talking to people, learning from the people that you are serving. I can tell you a story. I went and talked to an engineer. I won't mention names. This was again in Jaffna 2 years ago, and asked the engineer why there's so much misinformation about the desalination plant in Jaffna. Why are you not communicating this? What I heard was very reassuring to me, but the engineers were not communicating that to the people, and he told me that it will only open up a whole can of worms. He told me bluntly that he knows what the people want, and he doesn't need to consult them. So I think that mindset has to change. I think that the people have a lot of wisdom. I mean, you heard from my colleague Nihal Fernando that we have a history. We have a history of water management in this country. The people have wisdom. our culture, our history has wisdom built into it, and we have no way to build that wisdom into our Western style education and models and management schemes. So I think that there's a lot we can do to to take us on a new path, a different path than what we have done in the past.
Okay, I think now those who are interested in reading Dr. Romita's and Professor Nakamura's paper, the link to that paper is now in the chat box, so you can see that paper to see that application in Sri Lankan context. And also there are a couple of questions related to application of AI and machine learning in social hydrology.
Okay.
So what are your thoughts on that?
Okay, this is this is a controversial question to ask me because I have a very strong opinion on this. Um, I the number one thing is I'm not against technology, any kind of technology. It's fine. So AI it's a technology if we use it as a technology. But I believe more in the ability of the human mind. And I think that we should give priority to human mind, human understanding. And so long as we treat the AI as a tool and not become a slave to it, I'm fine. I think the danger is that some people may become slaves to AI, which I hate. But you might ask me about AI now. 10 years now, there'll be something else. This is what happens in science. Technologies come and go, but the fundamental questions never go away. They are always there. So if you tie yourself to more fundamental questions and answering fundamental questions, you'll be fine. So don't become a slave to any technology.
Okay, I think that's a very clear answer. And Professor Siva, one of our participants, I think Engineer Edward, he's asking for the link to access your new book. I think later on, if you can share that link
Yeah, I
with
will
me, I
share it
can.
with you. It's actually, well, the book only came out last week, and there's a hard copy version which is selling for $150 or something like that. But there's a open access version which is anybody anywhere in the world can download free, and that link has not appeared yet. So as soon as that is available, I will share it with you, Shamal, and you can share it with
Sure,
everyone.
yeah.
It's a fantastic book. It summarizes everything that we have done in the last 12, 13 years in sociohydrology, and it's written in a style that is aimed at basically early career scientists and students. So it's a good teaching book. So I think you should all download it and use it wherever possible in whatever ways. I'll appreciate that if you can use it.
Okay, thank you very much. I think we are almost running out of time. So if there's anyone who wish to direct a question to Professor Siva, so you are welcome to unmute and direct the question, or if you have any comment, so please go ahead.
Shamal, I think also I'm perfectly okay for my PowerPoint presentation to be made available to anyone who is interested,
Sure,
also the recording. So I'm perfectly okay with that.
Thank you very much, Professor. Later on, I think you can share the presentation with me, and I will share the presentation with our participants.
Thank you.
And I think Engineer Nalin Vikramanayaka has raised the hand. Could you please unmute and raise your question, or if you have?
Have there been any analysis of a purely urban water supply situation with the influence of different tariffs and things like that, and the
That's
response?
a very good question. Uh, yeah, there's one chapter in our book devoted to urban water supply, So there has been some work in looking at the urban water supply from a social hydrology perspective. Yes, there has been whole chapter devoted to that. So I think that if you, I mean, I can
Because
share that.
in Sri Lanka, we had gone through this where the rates have gone up quite a lot after the economic crisis and the water
Yeah.
board having become cost effective. So it's
Yeah.
very interesting. And they have all the data to find how many people have stopped using water, may have gone back to wells and things like that.
Yeah, I
So
think that's a very good point. And I myself have not done so much work in urban water supply, but I think that there is quite a lot of research done on that. And but I think a lot more to be done. I agree with you. A lot more to be done, but it's happening. And this book, when you download it, you will find that the literature there, and hopefully that will guide you. I myself want to do more work in that area. It seems very interesting. But yeah, uh, I agree with you. Thank you.
thank you very much.
Okay. Thank you very much, everyone. I think we had a lot of questions, and Professor Siva, thank you very much. So keeping this you so long. Um, I think now we have come to the end of our session. Um, Thank you very much again, Professor Murugesu Sivapalan, for that truly inspiring presentation and also for the very long discussion. I think one key message today is that being a good engineer requires more than understanding of hydrology or designing technical solutions. So we must also appreciate the social, cultural, and the human dimensions of the water system. I think that is one of the key things highlighted today. So if the solutions we propose are not socially acceptable, or if it is not aligned with the people's everyday realities, then even the most sophisticated engineering interventions can fall short. So I think that is very important. So we have spent almost 2 hours together, and despite today being the Thanksgiving in the United States, Professor Siva took the time to be with us early in the morning. So we are deeply grateful for that generosity. So Professor, thank you once again for sharing your knowledge, experience, and the wisdom with the Sri Lankan engineering community. And I also hope that we can continue this conversation and keep building awareness around these ideas. So at our university, at the University of Moroto also, now some of the students are studying these long-term human water dynamics. And with the support of our wider engineering community, so we can expand this work and improve our water management practices. And ultimately, we move forward towards a sustainable future. So that is all.
Excuse me, Dr. Chamal. Before wind up, we need the time to do the vote of thanks from the representing the both forums.
Yeah, sure. So that's all from my side. Thank you very much, and I would like to invite Engineer Janaki to go ahead with.
Dr. Anusha, she will do the vote of thanks.
Okay, Dr. Anusha, please go ahead with the vote of thanks. Okay, thank you.
Ladies and gentlemen, engineers and environmental scientists and other professionals, I'm Dr. Anusha Lalani Adrivira, engineer and chartered environmental scientist. And it's happy that this is our first ever webinar together, engineers and environmental professionals. So I think plans of steel, dreams of green, together they build a world more clean. Here we are together. So water management is shared responsibility where engineering expertise and environmental science unite to ensure the sustainable use, protection, and conservation of water resources. Engineers design and maintain efficient water infrastructure, while environmental professionals safeguard ecosystems and water quality. Together, they promote resilient solutions that balance human needs with environmental preservation for present and future generation. On behalf of IEPSL, that is Institute of Environmental Professionals Sri Lanka, I would like to extend our sincere gratitude to Professor Murugesu Sivapalan for sharing his invaluable insights on socio-hydrology and the interaction between society and water management. Your expertise has inspired us and enriched our understanding of sustainable water practices. We would also like to sincerely thank the Institute of Engineers Water Forum, Engineer Mrs. Janaki Megastanna, Engineer Mr. Dulanjan, Engineer Dr. Chamal Pereira, and the entire organizing team for their dedication and support in making this event a success. Finally, thank you all participants for your enthusiastic presence and engagement. Your interest is what makes such event truly meaningful. Once again, thank you, Professor Sivapalan, and everyone who contributed to this memorable session. Good night.
Thank you very much, everyone. So we will share the presentation later. And also the recording will be shared by the ISL. Thank you very much.
Shamal, I want to say one final comment actually. I have given this kind of talk in many different places, but I have to say that this was the best in terms of